Is the graph increasing or decreasing from -1 to 0? To me, this is the -1 to 0 on the x-axis. It looks like it's going down when I read the graph from left to right. So did you choose decreasing for that one? And then between 0 and 2 on the x-axis, it looks like it is increasing because it's this region of the graph, so it's increasing. Let's see, the x-intercepts. Did you write them correctly? So -1, 0 and +2, 0 and 4, 0. So there should have been 1, 2, 3 times that the graph crosses the x-axis, but only one time when it crosses the y-axis. It looks like 0, -4. Is that what you interpreted that as? It looks like. So this is evaluate, meaning find the y value when x is 3.5. This kind of looks like an estimate, but I'm guessing around 4. It kind of looks like that peak, doesn't it? 3.5, 4. Is that what you said? Okay. If you have a different estimate, let me know. That to me is the maximum of the function, right? The maximum is a y value of 4. The minimum is going down forever, so you should have written -infinity. Make sure you put a negative in front of your infinity sign because it should be going down forever, not up forever. Okay, a local minimum to me would be this point right here because the arrows are going down past it, but that is a valley. So I would say 0, -4 is a local minimum. And then to me, the local maximum would be this peak, this x-intercept, because the graph goes up and then comes down. This is called a point of inflection. So the graph is going up, it kind of flattens out for a second, but it keeps going up, going up, going up. A turning point has to go up and then come down. So to me, the local maximum was at -1, 0, and that was the only one. Did you say the domain was what? Yep. But that is the ultimate maximum. So to me, if it already is the maximum, I'm not going to call it a local maximum. If the arrow had continued to go up past that, then yes, that would have been a local max. So if there was like one of the legs of the graph going straight up past it, but to me, that is the max. This is the local max. So this is like the biggest. This is kind of like the second biggest, like someone said. Like this is the smallest, -infinity. This is kind of the second smallest. If you want to think of local as kind of the just less than. Domain, did you say all real numbers? My arms keep going out forever and ever and ever, but my range is not all real numbers. What did you say? The y values are what? Oh, you used 5. That's fine. If that's how you interpreted it, as long as you were consistent, I'm going to interpret it as 4 just because I want to be consistent. I would say either y is less than or equal to 4. If you want to include in fact that it goes to -infinity, you could say y is greater than -infinity but less than or equal to 4, something like that. How did you incorporate infinity into your answer? I did okay, as long as you wrote it like the bottom one, that's good. Just because sometimes people misuse the inequalities with infinity. Any questions on the front page? So if you were given a graph like this on your quiz, and I selected, 4 or 5 of these questions, you think you could answer them okay? Okay. And then let's see, the back page, is it increasing or decreasing from -2? And then, right, you guys were asking about how to label the x and y axis. It really should have been labeled for you, so I apologize. So I would interpret that first question that -2 to 0 is increasing because it's this stretch right here. And then when x is greater than 4, it looks like it is decreasing. Is that what you said? Coordinates of the x-intercepts, -2, 0, and +4, 0. We got that okay? That's how you're going to answer on the quiz. X, y. Don't just write the x value. The y-intercept is at 0, 2. Evaluate. What did you say for this one? When x is -4, what do you get for y? For part E. Positive what? Yep, because it's referring to this position on the graph. When x is -4, y is +4. Did we interpret that one correctly? Okay, so this next one, I guess, is up for interpretation. Did you think that this continued forever with arrows, or did you stop it at 14? I guess it depends on how you interpreted this graph. I'm interpreting it's cubic and it goes forever. But if you said that the maximum was 14, I didn't draw an arrow. So I would either count positive infinity, or if you wrote positive 14, those are both maximums to me. Oh, assume the graph continues off the axis forever. I did indicate that it goes forever. So to me, that is the correct answer if you read the directions, which I didn't. So the minimum, therefore, is negative infinity. Let's see, your local minimum was right here at -2, 0. Did you say that? Your local maximum was right here at 2, 4. That's the only one. The domain and range would both be all real numbers. I'm going forever off the graph in both directions. And what is the graph's parent function? How did you name it? Yeah, that is a really good interpretation that it's transformed up to. There's a little bit other changes that are occurring to make these bumps, these turning points, a little bit more severe, but that's a really good interpretation of the function and the parent function. I think this has also been flipped in the opposite direction, but we don't know enough about cubic, so to me, one of those answers would have sufficed as correct. All right.